For thousands of years, across cultures that had no contact with each other, humans have always insisted that the universe was made of vibrations. We called it poetic. Then one day we built instruments sensitive enough to hear it, to actually listen, and the universe answered back in 3 frequency bands: a sub-bass drone from a black hole, the mid-range chirp sound from the fabric of spacetime itself. Oh my God, I'm so excited about this one. And a shimmering high-end light that we translated into sound. Today I'm going to walk us through what we've actually recorded and why the oldest spiritual intuition, keyword intuition, on this earth turns out to be closer to physics than anybody expected. In 2003, astronomers pointed a telescope at a galaxy cluster 250 million light years away and realized they were looking at the oldest song in the universe. What you're hearing right here is not a simulation, it's a pressure wave. A real acoustic signal sped up so a human ear can finally hear it. The note is B flat, and its natural non-sped up version is about 57 or 58 octaves below anything a piano can ever reach. Most of us at some point came to the conclusion that there was no sound in space. It's one of those things that sometimes you just accept and stop thinking about. And it's almost true, because sound needs a medium. It needs something to push against. In the vacuum of space between stars, there's nothing to carry that vibration. But galaxy clusters are not empty. The Perseus cluster, at the heart of its 1,000 galaxies or so, it's filled up with this giant cloud of superheated gas. It's very fragile or fine, but it's very real. And at the center of this cloud sits a massive black hole. And it's constantly shooting out jets of energy that inflate big bubbles in the surrounding plasma. Those bubbles act like a cosmic piston. Every time they expand, they push gas out. And that push travels through that cluster as a pressure wave. A pressure wave through any medium is the literal textbook definition of what sound is. Astronomers measured the spacing between those ripples, a period of a single oscillation, one full wave cycle, turned out to be roughly 10 million years. That's just one vibration. Every 10 million years, if you translate that into a pitch, it lands on B flat, 57 octaves below the B flat, above the middle C on a piano. Now, if you want to compare that to something, an entire piano is made up of about 7 octaves. We're talking 57. This note is so deep. It's more than 1,000,000 billion times lower than the human ear can detect. In 2022, NASA released a listenable version of this so we could all experience and listen to something close to what the universe actually sounds like. They took the pressure wave data from Chandra. Chandra is NASA's X-ray Observatory, and they scaled it up 57 or maybe 58 octaves, which is 144 quadrillion times higher than its original frequency, and 288 quadrillion times higher on the harmonic above it. What came out was this. That is the deepest note ever detected in the entire universe. Ever. An actual, continuous, measurable acoustic oscillation sustained for 2.5 billion years. Before life on Earth. Before Saturn got its rings. Before the concept of time. This note has been playing the entire time, a very low B flat. Now, if the Perseus black hole is the universe's subbase, a drone that's so deep it's practically geology now, then the mid-range of that mix comes from something that's a little different. It's louder in a way that your body can process it. On September 14th, 2015, not that long ago, something arrived at Earth that had been traveling for 1.3 billion years. 2 black holes. Each one of them was about 30 times the mass of our sun, and they collided into each other. They'd been hiding away in this binary orbit, spiraling closer and closer, faster and faster, until they ran into each other and fused together into a larger black hole. It released more energy in a fraction of a second. More energy than every star in the observable universe combined. I know that sounds dramatic. It's real. Space drama. When something that violent happens, it doesn't just send out light and heat. It sends out ripples in space-time itself. You get these gravitational waves, the same ones predicted by Einstein in 1916. And for 100 years, nobody could prove that these waves existed. The distortions are so small that by the time they reach the Earth, they stretch and they squeeze the entire planet by less than the width of an atomic nucleus. Teeny tiny gravitational waves. Then we built what's called LIGO, L-I-G-O, 2 observatories, thousands of miles apart, with 4-kilometer-long laser arms measuring distances with this ridiculous precision. And on that day in 2015, both of these monstrous observatories, 7 milliseconds apart, picked up exactly the signal that Einstein's math said should be there. It swept upward in frequency over about 1/5 of a second from 35 hertz to 250 hertz, which is the perfect range for us to hear. 35 to 250 hertz is not a random range. That's our range. That's what we've been built for. That's the sweet spot of the spectrum that humans are always tuned into. When you take LIGO's measurement of space-time itself stretching and squeezing, and you play that strain data as audio, you don't have to transpose it a bunch of octaves. You just hear it. That sound is not a translation of light. It's not pressure through gas. It's the fabric of space-time really vibrating. And it just happens to be vibrating in a band that our ears can pick up. Every black hole merge detected since that date has made a similar chirping sound. Each one has its own unique signature, different masses, different spins, different approach angles. Scientists at a Caltech have even mapped black hole vibrations onto the 88 keys of a piano, a carillon of dead stars. And I think it's really weird that chirping mimics the calls of real birds here on Earth. Anyway, that's the mid-range of the universe's mix. It's transient energy. It's short, sharp, hit you in the chest notes. Our own galaxy has a supermassive black hole at its center. It's called Sagittarius A star, and it sits about 26,000 light years away. We've got images of it. We've watched and studied across almost every wavelength that we can detect. And a few years ago, we sonified it. Now I'm saying sonified instead of recorded because this one's capture is slightly different. Sagittarius A is not loud enough in pressure waves to give us a drone like Perseus does. And the black hole at the Milky Way's center, it's not merging with anything right now, so there's no chirp. What we have instead is light, X-rays, radio waves, infrared. So scientists did something more interpretive this time. They took the image data and they mapped it to sound. Brightness became your volume. Distance from the center became pitch. Light further out was played at higher frequencies, light closer in at lower ones. A radar sweep thing moves through the frame, and the picture plays like a score. Here it is. This is not acoustic sound like we're used to. Nothing physical is vibrating through the gas here, but the information here is real. And when you render it this way, something happens that's just kind of weird. You can hear the structure that you can't see. Bright knots of gas become bells. Diffusion in the fields become wind chimes. The black hole becomes a kind of silence at the very center, a place where the notes can rest and go quiet. This is the high end of the mix. It's that same atmospheric shimmer that we all want in our mixes so they don't sound so muddy. The part a mixing engineer would call air. Now just pause and take this in for a second. If you've ever mixed a track or painted a picture or composed a scene for film, you know that a complete piece needs all of its range. You need that low end to ground you. You need something in the middle that hits the body, hits the soul. And you need that brightness for depth and air and dynamics. And our universe has all of it. A sustained 2.5 billion year drone, which I'm just fascinated by. From the deepest parts of a galaxy cluster, you've got short, violent chirps from collisions of dead stars. You've got your shimmering atmospheric top end from light translated into frequency. The universe has a mix. None of this technology I described today existed before the late 20th century. LIGO came online in 2002. Chandra found the Perseus note in 2003. The first sonifications were released in just the last 5 or 6 years. On the timeline of human civilization, we have known about any of this for about as long as it takes a child to grow into a teenager. That's not long. And yet, for thousands of years, cultures that had no contact with each other, separated by oceans, by centuries, by entire cosmologic worldviews, they all kept saying the same thing, that the universe began as a sound, that existence is vibration, that to align yourself with something larger, you have to listen for a frequency. In the Vedic tradition of ancient India, there's this concept called Nada Brahma, sound is God, or more precisely, the universe itself is a sound. The syllable Om, chanted for thousands of years, is understood as the primordial vibration from which all form emerges. In Pythagorean Greece, more than 2,000 years ago, the philosophers spoke of musica universalis, the music of the spheres. They believed every celestial body rang with its own tone, and that the planets together formed a cosmic chord that most humans were just too ordinary to hear. In Yoruba cosmology, a beautiful culture from West Africa, there is Ase, the living vibrational force that authorizes existence itself. To speak a thing with Ase is to make it real. In ancient Egypt, the god Ptah was said to have spoken creation into being, not built it, not shaped it, but said it. The Egyptians practiced Heka, words of power, for the same reason. Every ritual tradition has always chanted things, because the right frequency, sustained, was believed to move the world. In Aboriginal Australia, there are song lines, the idea that the land itself was sung into being by ancestral beings, and that walking the correct song is how you keep the country alive. In the Christian mystical tradition, in the beginning was the Word. In Kabbalah, the universe is spoken through the vibrations of Hebrew letters. In Sufi practice, zikr, the repetitive vocal vibration of divine names, it's a doorway. Tibetan monks chant in deep overtones. Indigenous traditions across the Americas drum in frequencies that entrain heartbeat. Medieval European monasteries were literally built to resonate at specific pitches. These cultures were not copying each other. Most of them couldn't have been. And they were not wrong about something metaphorical. They were describing, in the language that they had, an actual feature of reality. The fabric of the cosmos is oscillatory. At every scale, from the deepest black hole in a cluster 250 million light years away, down to the quantum behavior of a single particle, existence behaves like a wave. I'm not saying that science has proven mysticism. I'm saying something quieter than that. I'm saying that that intuition was correct. Human beings have been reaching towards the same truth from two different directions for a very long time. The mystics came at it through the body. Physicists came at it through math. And they seem to be coming together into the same room with each other. Every tradition I mentioned in this video developed in a response to a real human need. The need to feel connected to something larger than just that small window of a human life. The need to believe the silence around us isn't actually silent. To believe there's a presence, a voice, a continuity inside this void. We used to think that need was spiritual. And it is. It's also very accurate. The void is not silent. It never has been. It's a continuous B-flat, holding steady in a galaxy cluster 250 million light years away that has been sustained longer than anything our species has ever built. When two of the darkest objects in the universe collide, they don't just disappear, they ring like struck bells in the exact frequency range of human hearing. And when we point our most sensitive instruments at that black hole, at the center of our own galaxy, we get a shimmer, a chorus, something that sounds remarkably like music. The people who built monasteries for resonance and chanted syllables into the dark and pressed their foreheads to the ground in rhythm, they were tuning themselves to the universe. And maybe the reason a low drone moves us is that we are instruments inside a much larger instrument, made of the same physics, resonating at frequencies that were singing a long time before we even had ears. The universe has a voice. It's always had one, and we're just finally becoming open enough to hear it.